Hi my scholars, this is my school channel and my name is Abiola. Remember, in this channel you'll be joining me to solve the JAMB CBT past question for the subject Physics 3 year 2012. Do not go anywhere, stay with us, cause we'll be right back. Welcome back to my school YouTube channel, and in this video segment you'll be joining me to solve questions 15 to 28. So let's start with question 15. Okay, two metals P and Q are heated through the same temperature difference. So temperature here is just constant. The temperature difference, theta 2 minus theta 1, they are the same for both metal P and metal Q. So we are not working around temperature. Okay, so if the ratio of their linear expansivities of P to Q is 2:3, that means linear expansivity of P is 2, that of Q is 3. Okay, so and the ratio of their length is 3:4, that is length of P, original length of P is 3, original length of Q is 4. Okay, just take note of these values we've presented respectively. Okay, so the ratio of the increase in length of P to Q will be what? So we're just going to use linear expansivity equals increase in length over original length times change in temperature. This is what I mean. So linear expansivity for P, okay, will be increase in length L2 minus L1, or I can use delta L, anything I want to use, over original length, right? Okay, times delta theta. We know that theta is now constant for both metals P and Q. So increase in length is what we are looking for. That will be L2 minus L1, okay, for P will be linear expansivity of P is giving us 2, all right, times the original length of metal P is giving us 3. Okay, so we can see that the increase in length for P is 6. Okay, so let's see the increase in length for Q. That will be the same thing, L2 minus L1. We don't need to go through these formulas again once you just cross multiply. So L2 minus L1, this is for Q, right, will be equals to the linear expansivity of Q, we are given as 3, and the increase and the original length is given as 4. So that is 3 times 4. That is 12. So we are asked to now find the ratio of the increase in length of P to Q. So this is the ratio of increase in length for P, increase in length for Q. So that will be 6:12. Right? That is 6:12. Okay, that still means 6/12 or 1/2 or 1:2. Whatever thing we want to use. So let's go back to the screen and pick out 1:2 or 1/2, or possibly 0.5 if given in decimal form. So we can find 1:2 in option A, so option A is the correct option. Question 16. 2000 centimeter cube of a gas is collected at 27 degrees Celsius and 700 millimeter mercury. Okay, so what is the volume of the gas at standard temperature and pressure? So we just have to use P1 V1 over T1 equals to P2 V2 over T2. So we have to make V2 the subject of the equation or the formula. Okay, so what do? We cross multiply, this comes here. So I would have in P2 V2 T1 equals P1 V1 T2. We're asked to make V2, so we divide both sides by P2 T1. So we can confidently tell that V2 equals P1 V1 T2 over P2 T1. So let's just impute the values provided. So we have P1 as 700. Okay, then V1 is given as 2000. Then T2 at STP, remember that is 273. Then we are given P2, remember again at STP that is 760, times T1 is given as 27. So 27 plus 273, Kelvin scale, that makes 300. So I can do this, right, okay, and we can still do this. I can do this, year 9, year 1. So if we multiply whatever we have on top divided by what we have beneath, we should have 1676.315 thereabout. So roughly 1676. Okay, let's see if we have this given to us in the options provided. 1676.31 thereabout. Okay, of course we can find that in option C. So option C is the correct option. 17. Calculate the temperature change when 500 joules of heat is supplied to 100 grams of water. So we have to bring this gram to kilogram. Okay, so that will be 100 divides 1000. That is 0.1 kg. So let's work around our formula. Remember, we have H equals mc delta theta, where this is the temperature change we are looking for, dividing both sides by mc. So we know delta theta equals H over mc. Quantity of heat supplied, of course, we know it's 500 joules over the mass of water, which is now 0.1, okay, times for water, okay, which is 4,200. Specific heat capacity of water. So 0.1 times this, that still gives you 420, right? So 0 strikes out 0. So I have 50 over 42. I can decide to do this. Okay, so what can work around there? I can still break it down. 2 year 25, yes, 2 year 21. So I have 21 over 25. When I make this division, it should be somewhat around 1.19104 thereabout. So roughly I can bring it to 1.2. Okay, this 9 given to this, so 1.2. Let's see if we can find 1.2 in the options provided. Okay, so join me as we move back to the screen. Of course, we can find that in option C. Remember, the units for temperature is Celsius, degrees Celsius, or if you want to use Kelvin scale. So we have option C, 1.2 as the correct option. 18. Which of the following is not a factor that can increase the rate of evaporation of water in a lake? So at first we should just remember that evaporation, you know, is when a liquid turns spontaneously into vapor, okay, below melting, boiling point, rather below boiling point. So you know, it occurs at all temperature, but there are certain factors that can influence the rate of evaporation. You know, when you talk about temperature, an increase in temperature will increase the rate of evaporation, okay. The movement of wind, okay, and the drier the air, just like Harmattan season, you realize that your clothes being spread gets dried faster, okay. So good movement of the wind and drier air, okay, increases the rate of evaporation, okay. And also when we talk about nature of the liquid, okay, so liquids with lower boiling points tend to get evaporated compared to those with higher boiling points, okay. So and as well, we can look at all of these put together. So we can see that an exception here that I'm here to mention is that when you increase pressure, the greater the pressure, the slower the rate of evaporation. So the question requires that which of the following is not a factor that can increase, okay. So if you increase pressure, you are not increasing the rate of evaporation, you are decreasing it, you are reducing it. So this is one thing I'm looking at, which is option A. So option A is an exception that we are looking for. Question 19. The quantity of heat required to melt completely 1 kg of ice at minus 30 degrees Celsius is what? So we are given lattice of fusion, we're given specific heat capacity of ice and what have you. So we're just going to use this very simple formula, okay? So for the quantity of the total quantity of heat required, we're talking about this mc delta theta, right? Then added to Remember, specific latent heat of fusion. Okay, so that is what we are looking at, and that is giving us ml. Okay, so from here we can see that m, the mass, is 1 times c that we are given is c is given as 2.1 times 10 raised to power 3. Okay, or that is 2,100. All right, so the change in temperature, it is 0 minus, let me show you what I mean, minus 30. 0 minus, change in temperature is, okay, 0 minus 30. We have minus 30 from the question. Then we have 1 times, we are given L as 3.5 times 10 raised to power 5. Okay, that is also equivalent to 350,000. All right. Okay, so 0 minus times minus, that is plus. So it's 0 plus 30, that is still 30. So 30 times this, just ignore the zeros first. 3 times 2, that is 6. 3 times 1, that is 3. How many zeros? 1, 2, 3. Okay, 1 times this is still the same thing. Okay, so if we add up, we should have 413,000. Okay, just add it up and this is what you should have. So if you want to bring this to standard form, I can decide to count 1, 2, 3, 4, 5. Okay, so let's see if we have this given to us in the options provided. Okay, remember the quantities of heat is measured in joule, units for heat joules. Okay, so the correct option is option B, 4.13 times 10 raised to the power 5 joules. I know you would like to better prepare for your coming exams. All you need to do to get the Myschool mobile app or the Myschool software is to click on the link in the description below. It's going to take you to the Myschool website. There you can get any of these Myschool tools made readily available for you. So join me as we solve question 20. Okay, so let's take the question first. We are told that okay, which of the combinations above is correct about Brownian motion? Okay, at first, Brownian motion is about the rapid, constant, irregular motion of tiny particles. Okay, so this is correct, statement 1. Let's look at statement 2. It gives evidence that tiny particles of matter exist that we call molecules. Of course, you can see this from Robert Hooke. All right, so let's look at 3. It takes place only in gases. This is incorrect. It takes place in solid and liquid. So saying only in gases is no, is an exception. Okay, in short, during the course of the experiment, it was examined using pollen grains in water. Okay, with the aid of a microscope, of course. So this is out of it. So it gives evidence that molecules are in a constant state of random motion. So statements 1, 2, and 4, they are correct about Brownian motion. Okay, though we have other phenomena, natural phenomena like diffusion and osmosis that buttress this nature of matter. So let's go back to the question given us. So the statements correct, they are 1, 2, and 4. 3 is incorrect. So we have option D. Option D is the correct option. So if you want us to do more of this kind of work, all you need to do is to hit that like button, also click on the subscribe button, and always tap on bell notification so you can get alert immediately we upload the next video segment just for you. 21. The equation of a wave traveling in a horizontal distance is expressed as y equals 15 sine 2 over 5 60t minus x. Okay, so what is the wave? Well, what is its wavelength? Let me just show you where this equation is coming from. When you talk about the equation of the traveling wave, okay, so generally we can use this. Okay, so we have y equals to a sine. This is your angular velocity. Okay, then this is your phase constant. And remember that we can use phase constant equals 2 pi x over wavelength. So when you slot that in, you should have this derivation. So either you can use this for plane progressive wave. Okay, so just work around equation for a traveling wave. So when you substitute this phase constant, then you should have this. So if you look at the value that was given to us, we have from the screen, we have y equals 15. That is A, your amplitude, sine, okay, 2 over 5. So that tells you that the wavelength here is 5. You see that now. Then we have V, and the V is given as 60t minus x. So this is what they use. So if we use this equation to identify the parameters given, so this is your amplitude, which is given as 15, okay? Then we have your sine, which is also present. Then we have your 2 pi over the wavelength. So you can see the wavelength here, and it's given as 5 from the question, 2 over 5. This is it. Then this is your V, which is given as 60t minus x. So your wavelength is 5 without solving anything. So let's go back to the screen and pin out where we have 5. Of course, you can use other methods to get this, but I believe this is just more relatable. So we have that in option C. So option C is the correct option. 22. Which of the following factors will affect the velocity of sound? Okay, so let's look at the factors at first. We talk about temperature and elasticity of the medium. That's why when you compare the speed of sound in air compared to water, you can see which is higher, okay, based on density differences. Okay, so that is one. We talk about temperature too. So when you notice the increase in temperature, you will see the effect on the velocity, or to simply put, the speed of sound. Let's just talk about speed of sound. Okay, then another thing we can consider is wind. Okay, so if the sound is traveling in the same direction just as the wind, okay, it's going to cause an increase. So if you look through the options, we have wind. So which of the following factors will affect the velocity of sound? That is wind traveling in the same direction of the sound. Option C is the correct option. 23. The characteristic of a vibration that determines its intensity is the what? So when you talk about factors that influence intensity, you are looking at amplitude of vibration, frequency of the sound, and distance from the source of the sound. Okay, so this is what we can talk about. So I've mentioned amplitude of vibration, okay, frequency of the sound, and distance as well. So the correct option here is option D for amplitude. Do not forget to use the link in the description below. Once you click on it, it's going to take you to the Myschool website. Okay, so there you can ask your questions right now. Once you do so, our solution providers are going to help you out. So join me as we solve question 24. Where can a man place his face to get an enlarged image when using a concave mirror to shave? Okay, so this is what he's going to do. He's going to bring his face nearer. Okay, he's going to come nearer to the concave mirror, all right? And that means it's being positioned between the principal focus and the pole. Okay, this will give him an enlarged image, an erect image, and a virtual image. Enlarged, erect, and virtual. So when it is being placed between the principal focus and the pole, that is when you can get this. Okay, so the correct option here is option C, between the principal focus and the pole. We believe that you may have better steps or explanation in tackling any of the questions we have solved so far. Please, we'd like to know. All you just need to do for us is to use the comment section below. Kindly indicate the question number and the explanations you'd like to share. 25. A pinhole camera is placed 300 meters in front of a building so that the image is formed on a screen 5 centimeters from the pinhole. Okay, so if the image is 2.5 centimeters high, the height of the building will be what? So we are just going to use this formula for magnification. Okay, the size of the image, or we can use the height of the image equals the image distance from the pinhole camera and the object distance as well. So since I have height and distance now, so I'll just say, okay, the image height is given as what from the question? We are told if the image is 2.5 centimeters high. Okay, so the object height is what we are looking for. That's for the building. Okay, so let's look at the object, the image distance or object distance as well. We told a pinhole camera is placed 300 meters in front of a building. So the building and the pinhole camera, that is object distance, is given as 300, and the image distance, okay, is given as what? Is given as 5, so that the image is formed on a screen 5 centimeters from the pinhole camera. Okay, so remember from the formula we just said, magnification equals this, right, over this equals, you can say D over OD. So from the question we are asked to find the height of the object or the height of the building. when we cross multiply, that will be right equals dividing both sides by this. Okay, so what is our object distance? That is 300 times the image height, that is given as 2.5, over the image distance, which is given as 5. Okay, so we know 2.5 here 1, 2.5 here 2. Okay, so 2 here 1, 2 here 150. So what we are looking for is 150. Okay, so let's go. That is the height of the building. That is 150 centimeter high. So let's see if we have that in the options provided. Okay, so we can see that that is given as 150. Okay, sorry about the units, 150 meters. So option D is the correct option. 26. The magnification of an object 2 centimeters tall when placed 10 centimeters in front of a plane mirror is what? So when you look at the features of images produced by a plane mirror, you just know number 1, it is virtual, it is erect, it's the same distance as the object. So object distance equals image distance, and the size of the image equals the size of the object. So the magnification of that image or magnification produced by a plane mirror will be unitary, that is 1, because the image height is the same thing as the object height. So that will be image height is 2, object height is 2, that is 2 over 2, that is 1. Okay, so they are the same. Image distance equals to object distance. So for a plane mirror, if you are having any exception, probably the distance or the height of the image produced is smaller or larger compared to this that you are having. It tells you that the mirror isn't flat or plane to be put, or flat. Okay, simply put. So that is 2 over 2, that makes 1. So it should be unitary. Option B is the correct option. Number 27. After reflection from the concave mirror, rays of light from the sun converges at the real focus, okay, or the principal focus, okay. It's that point on the principal axis, you know, either for a convex mirror or for a concave mirror. For a concave mirror, this is where you notice there is converging, okay. For a convex mirror, you will notice that, okay, they diverge from there. So for a concave mirror, it converges. And of course, the principal focus is known as the real focus for a concave mirror that we're dealing with. Also, for extra information, you know, the essential part of a spherical mirror, we are talking about the aperture, you are talking about the radius of curvature, you're talking about the center of curvature, you're talking about the principal axis, we are talking about the pole. So the correct option here is option B, at the focus. 28. A glass block of thickness 10 centimeters is placed on an object. Okay, if an observer views the object vertically, all right, so the displacement of the object is what? So we are just going to use refractive index, okay, equals real depth over apparent depth. So we know refractive index for glass is 1.5 equals the real depth from the question is 10 over the apparent depth. Okay, that will be x times 1.5 equals 10. Dividing both sides by 1.5, we should have 6.66666, so I can just put 6.7. Okay, so therefore the displacement that have occurred, this is the apparent depth now. So the displacement that have occurred will be this minus this. So 10 minus this. Okay, I can just do this. Minus 6.67. Okay, let's do this ourselves. This is not possible, right? So we have to lift 1. 1 from here is 10. Okay, 10 gives to this. This becomes 10. This becomes 9. This becomes 10. Gives to this becomes 9. This becomes 10. Okay, 10 minus 7 we have 3. 9 minus 6 we have 3. All right. So 9 minus 6 we have 3. This is 0. So we have 3.33 to put it that way. So let's go back to the screen and find out what the displacement is. Displacement, of course, is 3.3, so option A is the correct option. We've come to the end of this video segment, but there are more contents to come. All you need to do is to hit that like button, also click on the subscribe button, and always tap on bell notification so you can get alerts immediately we upload the next video segment just for you.